Hello, good morning, guys. So in the last class, we discussed about IP addressing, right? We saw what is an address, logical address, physical address, okay? Then we saw conversions from binary to decimal, decimal to binary, and some differences between the IPv4 and V6, right? That was the part we saw in the last class. And we saw about 5 classes. How many classes? 5. Which are the classes? A, B, C, D, and E, okay? Then we also came to know that, okay, if we discuss about class A range, so that is from 0 till 127, the first octet range, correct? Then 128 till 191, right? Then 192 to 2 to 3. After that, 2 to 4 till 239. Not 37, 39. 40 till 255. These are the ranges. Okay. Now the class A range, sometimes it is written as 1 to 126. Somewhere you'll see it as 1 to 126. Why? Because the first network, that is 0.0.0.0, we do not use this. This is not used anywhere. Okay. And the second thing, 127.0.0.0, this is reserved for loopback. Okay. This is reserved for loopback. And this one is not used anywhere.
Excuse me, sir.
Yes.
In MCQ, you got both options.
Which one?
0 to 127 and 1 to 126.
Then this will be differentiated in the question. It will be clearly mentioned that the usable range or the range. So if we discuss about usable range, so this is only what we can use. We cannot use 0 till 127. So that will be mentioned inside the question. Okay.
So this will apply only class 1.
Yeah, only class A. Okay. Then after, only class A, B, and C. Okay. These we use for the assignment purpose. If you want to assign an IP address, yes, then we can use only class A, B, and C. These are the classes we can use for assignment. Then class D reserved for multicast. And E reserved for research purpose. Okay. What is multicast? 1 to, not all. 1 to many, but not all. Okay. All right. So this was the part we discussed in the last class. And there was some task for you, right? The first was? Yes, what is IPv5? Do we have IPv5? Yes or no? Yes. Have you seen anywhere?
No, sir, we don't have.
Actually, IPv5 was not officially adopted. Okay, it was known as Internet Stream Protocol, but it wasn't officially called IPv5. Okay, it wasn't an addressing protocol. And finally, it was replaced by the technologies like MPLS. Okay, so kind of you can say we do not officially have IPv5. And this in why we are saying calling it as IPv5, because see, whenever we will discuss about IP headers, okay, so there will be version information. So your internet stream protocol, that will use version number 5 in the protocol field. Okay, in the version field, that will use the number 5. So that's why when new IP addressing was getting designed, they came up with IPv6, so that people will not get confused between the internet stream protocol as well as the IP version 5. Okay. Then second task, subnet mask. So what is subnet mask?
Large network to
Subnet mask, not large network, not small network. What is subnet mask?
address host and network portion.
Network portion and
Host
host portion, right? So if we define how many bits is your subnet mask? 32 bits. Same with your IP address. Okay. So IP address is subnet mask, like your IP address, it is a 32-bit. So same way, your subnet mask is also a 32-bit binary number only. And what is the use of subnet mask? To differentiate between the network portion and host portion of an IP address. Okay. But before that, we need to understand what is the network portion and what is the host portion. So did you research about network portion and host portion? Because in the subnet mask, the words were there, right? Network part and host part, network portion, host portion, network bits, host bits, right? These kind of words you might have seen. So anything, did you research? No?
And then it cannot be changed. But subnetting we done on host part.
Subnetting, that is the subnetting. What is the network part and host part? We say your subnet mask divides or differentiate between the network part and host part.
Depends on the range, IP ranges.
Depends on the IP range. Okay.
That way we define what is the network person and host person.
So who will define?
Subnet mask.
Then why IP address class? See, remember the example of the university. In a university, we can be identified with two things. One is your enrollment number, and second thing is your, what is the second thing? Name. So again, let's discuss the same example. We have the university. Let's say this is ABC University. Okay. In this university, you can be identified with your name and with your enrollment number. Correct? Again, name was what? Physical or logical? Physical entity. And right now we are discussing about IP address. So that means we do not care about the name part, the physical entity. Right now we just care about the enrollment number part. Now enrollment numbers of an university, how they are? In the enrollment number, there is going to be a fixed part and there's going to be a variable part. Let's say if this is ABC University, so the enrollment numbers would look something like ABC, let's say 001. ABC 002, okay, ABC 003, and same way, let's say ABC 100. Correct? Now, if we see the enrollment number, so there is some part that is fixed, not changing. Correct? And there is some part that is changing. Now, if I talk about this fixed part, what it is telling you? Yes.
This is going to be a class or this is going to be a university name?
This is telling you to which university the student belongs.
Yes.
This tells you to which university the student belongs. And what is this part? The actual number of the student. The actual number of the student in the university. This is how it is getting displayed. Correct? Same way in your IP address. Now this is what? Yes.
Excuse me.
Yes.
CCNA is not
CCNA class.
yeah, I just wanted to join. I told Rupa yesterday. She told me to come for 8 days and then
Please come. You said Amit, so
they sent me a mail CCing Amit.
okay. Today is your first day. Can you please introduce
Yeah, sure. My name is Prabhu.
Prabhu?
Yeah. So I came to know about networkers from in decade back
Okay.
through my friends like me. So I have a 10 years of experience in network and security.
Mhm.
So I already did my CCNA like 10 years back, but I know that things are changing fast, rapidly. So I just wanted to take it up again. So in order to refresh my memory.
Great. Thank you.
Thank you.
All right. So we are just discussing about the subnet mask. So network part and host part. Now see. The fixed part that is telling you that, okay, which university the student belongs, and this is the actual number of the student. Same way when we discuss, when we're writing an IP address, okay, 192.168 dot, let's say 10.100. Now in this IP address, there has to be some fixed part and there has to be some variable part. Now who decides what is the fixed part and what is the variable part? that is being decided by your subnet mask. Okay. First of all, those two parts, they are known as network part and then host part. The network part, this is the fixed part or constant part. And this is the variable part. This part is the variable part. Means if we discuss about one network, same way if we discuss about one university, this will remain same. Same way if we discuss about one network, this network part will remain same. Okay. And the host part, it is going to vary. It is going to start from minimum and reach until maximum. Okay. So this is fixed. This is variable. See, this thing is, sometimes you'll also say it as a network bit, host bit. So your network part tells you to which network this particular machine belongs. If this is an IP address, in this particular IP address, there will be a network part. The network part is going to describe that to which network this machine belongs. And the host part, that will tell you that, okay, what is the actual number of the machine inside the network? What is the actual address of the machine inside the network? Okay. Now, how it is getting displayed, and we say that, okay, your subnet mask will decide. Because anywhere we see an IP address, see, whenever you see an IP address, always there will be a subnet mask mentioned. If I simply say IP config, see, everywhere you see an IP address with that subnet mask. IP address, subnet mask. That is everywhere. In case of IPv4, anywhere you're going to write an IP address, at the same place you'll also see a subnet mask. Okay. This is clear? Okay. So if you want to define the subnet mask, then how we can define? We can say that subnet mask, it is a 32-bit binary number that differentiate between the network part and host part of an IP address. Okay. Then what is the network part? Or network bit, what is it? It tells to which network a machine belongs. Means whatever is your node that is having the IP address. So your network part is going to tell you that, okay, to which network it belongs. Okay. And when we discuss about the host part, that is, it is the number, or you can say address of the machine in the network. Okay. Now, how does your subnet mask differentiate? How does your subnet mask differentiate or decides which part is the network and which part is the host? Okay. So we have seen the classes that we use 3 classes A, B, and C for the assignment purpose. So with each and every class, a default subnet mask value has been decided. For each and every class, a default subnet mask value has been decided. So what are those default subnet mask values? Let's say one side will have class, okay, and let's say default subnet mask. Okay, so first of all, if we say class A, so for class A, the default subnet mask value is 255.0.0.0. Okay, for class B, the default subnet mask value is 255.255.0.0. For class C, the default subnet mask value is 255.255.255.0. These are the default values. Okay, these are the default values. Okay, now let's say I will write one IP address. Okay, for example, 1.2.3.4. This is one IP address. Correct? Which class it is? Class A. We can just tell by looking at the first octet. This is a class A. So according to class A, what is the default subnet mask? 255.0.0.0. So one is IP address. This is your IP address. Right? And this is your subnet mask. Correct? Now what we are going to do, we are going to write both of these things in the binary. Okay, what is the binary value for 1? This one. For 2? 1 0. Then for 3? This one. For 4? 1 0 0. This one, correct? Oh. Now the same thing, write the subnet mask in the binary. All ones. Done. Okay. Now if you see in your subnet mask, there are ones and zeros. Okay. So whenever you write the subnet mask, all the ones, they will tell you that, okay, this part is the network. These many bits are the network. And all the zeros, they will tell you that this part is the host part. Okay. Now, if you compare the IP address, okay, from here I can say that the first octet, because complete first octet is what? 1. So this first octet, this is what? Network. And the remaining 3 octets, they are host. These remaining octets, they are what? Host. Correct? Okay. So if I want to write the IP range here, okay, if I want to write the IP range for this particular IP address, okay, so I need to keep the network part constant, because in the network, what is going to happen? The network part will remain same. So means this will remain constant, and the host part will start from minimum and go until maximum. So what will be the minimum value of these 3 octets? 0.0.0. Correct? And if I want to write the maximum range, what it will be? Network part has to be constant. 1.255.255.255. Because in any network part will always remain constant, and your host part, that will start from the minimum and go until maximum. Is that clear? Okay. So means what I can say here, that my first octet is what? Network, and remaining 3 octets are host. So in your subnet mask, anywhere you see 1, okay, in subnet mask, if you have 1, that means that is a network bit. And if you see 0, that means that is a host bit. Okay. This is clear. This is how your subnet mask differentiates that, okay, this part is network and this part is host. Now I will create that same table again. Okay. I'll create the same table again. Again, I'm saying class. Then I'll say default subnet mask. Okay. Then I'll add 2 more things here. One is the network bit and second is the host bit. Okay. So if I go with class A, my default subnet mask is 255.0.0.0. This is my default subnet mask. Now, looking at this default subnet mask, tell me how many network bits are there? Number of network bits. I converted it into binary, right? How many bits? 8. And how many host bits? 24. This is clear. What about class B? The default subnet mask is 255.255.0.0. What about the number of network bit and host bit? 16 and 16. Okay. What about class C? 255.255.255.0. Number of network bits? 24. Number of host bit? 2. This thing is clear. Okay. So we came to know how many network bits and how many host bits. Okay. So now if I ask you, let's say for example, this is one IP address. 1.10. Okay. Which class it is? So what will be the default subnet mask here? 0.0. So according to this, if I want to write the IP range, what will be the IP range? Which part will be constant? Network part. What is the network part here? 172.16. This is the network part because 2 octets are what? 255. That means 2 octets are 1. This will remain constant. The starting IP address will be 0.0. And what about the maximum? 255.255. This thing is clear. Okay. Let's say 223.0.0.1. Class C. 223, right? So default subnet mask. Correct. IP range till. Correct. This thing is clear. That means your classful subnetting is done. Okay. When we'll discuss about classful subnetting, you'll say that okay, this thing we have done, and this is how we do it. Okay. We just decide what is the network part, what is the host part. Keep the network part constant. See, if you want to master subnetting, this is one single concept. That always keep, first of all, decide what is the network part and host part. Okay. And based on that, keep your network part constant and host part, start it from minimum, go until maximum, your subnetting is done. Okay. Now see. Network bit, what is a network bit? Represent the network to which a machine belongs. Host bit represents IP address of that particular machine. What is a subnet mask? So we were deciding subnet mask. So about subnet mask, we said it is a 32-bit binary number that differentiates between the network part and host part of an IP address. Okay. Now with subnet mask, you have to remember few things. What are those things? Let me write here. in subnet mask, all ones, okay, will be on the left and all zeros will be on the right. It will never happen that you have ones, zeros, no. If there are ones, they will be all on the left. If there are zeros, they'll all on the right. Means, if I say all ones on the left, all zeros on the right. So this is a correct subnet mask. Correct? But if I say the same thing like this, let's say, for example, now this is incorrect. Now this is incorrect. Why? Because we have 1 0 1 0. No, it will never happen. Not a single one will be there. All the ones will be on the left, all the zeros will be on the right. Okay. So that means if I write a subnet mask, let's say 255,000, is it correct or incorrect? Correct. If I say 255.0.1.0, that will be correct or incorrect? What do you think? Incorrect. Anyone saying correct?
Subnetting mask.
Yeah, subnet mask, not an IP address, subnet mask.
Correct, sir.
Correct. Okay, you are saying it correct. Incorrect. Correct or incorrect? What we are saying here?
Correct.
Incorrect.
Simple. All the ones will be on the left, all the zeros will be on the right. So this is again incorrect. Not a single one will be there in between. All the ones always on the left, all the zeros always on the right. Okay. Okay. So what is a subnet mask? A value which helps to identify the network portion and host portion of an IP address. In binary format, it consists of continuous ones. So first of all, there will be continuous ones and then continuous zeros. So means all the ones on the left, all the zeros on the right. Network bits are represented by ones and host bits are represented by zeros. This is clear? Okay. Then we have seen the default subnet mask. For class A, it is 255,000, right? And if we write this thing in the binary, all ones, all zeros, and all zeros. So when we are having ones, that means this is the network part and remaining 3 are host parts. That means 8 network bits and 24 host bits. Same thing with the class B, 255.255.0.0. That means ones, zeros, and zeros. So ones are network, zeros are host. 16 network bits, 16 host bits. Then again class C, 255.255.255.0. Then ones, and zeros. So 3 network, that means 24 network bits and 8 host bits. This is clear. What about class D? What is the default subnet mask? 32. No. We do not use it, so there is no subnet mask. For class D and E, there's no subnet mask. Okay. So there will be no network bit and host bit. These are individual addresses. These are not network part and host part. There is no network part and host part inside your class D and E. These are individual addresses. One single addresses. And when we come across the dynamic routing, there you'll see that the protocols are using one single addresses. Okay. In them, they do not have the network part. Why we need the network part? First of all, it tells to which network the machine belongs. So means in one network, there will be multiple machines. Correct? If I say, let's say, for example, if we are writing this range for one easy range, let me write. Let's say if I give you this IP address 192.168.0.1. So according to this, your subnet mask default will be class C. Correct? And you're going to give the IP range something like 192.168.0.0 till 192.168.0.255. Correct? So you can see how many addresses are there from 0 till 255. Total how many addresses? 256. That means these many addresses are there inside one network. Correct? So why we require multiple addresses in one network? Because we want communication inside one network. Because remember the switch. What is a switch? Connects multiple networking devices into the same network so that they can communicate, exchange the data, share the things, right? So here we want communication between multiple machines, but these are individual addresses. The class D and the class E, these are the individual addresses. We do not require multiple machines to communicate. Okay. Here what will happen? Machines or the protocols, they will be listening on one address. And if they are listening on to one address, they will get the data, otherwise not get it. See, it's kind of, if you are part of a WhatsApp group, you'll get the information from the group. If you're not part of it, you'll not get it. Okay. This thing is clear. So for class D and class E, there is no subnet mask. Okay. Now, based on this information, we are going to make some calculations. Okay. We will try to we will try to calculate how many networks are available inside class A, class B, class C. And in one network, how many IP addresses we can get. Let's say this is class C. So we were easily able to calculate that, okay, 0 to 255, how many hosts? 256. But what about this 0.0 till 255.255? How many hosts? How many IP addresses? Because here network part is what? This part is the network, right? Only this part is the network. This is host part 0.0 till 255.255. So if it was 0 to 255, we can say 256. But now this will go multiple times. How many times? 256 times. Right? So this thing we need to calculate. So first of all, let's go with the class A. So if I go with the class A, how many network bits are there? 8. How many host bits are there? 24. Correct? Okay. So if I say total network bits, so I have 8 bits. Correct? Now out of 8 bits, when the classes were getting divided in the first octet, some part was reserved. Some part was fixed that we cannot change. Remember? When we were saying first octet range, in the class A, first bit was always 0. Correct? So that bit is fixed. We did not change that bit. So that means here, I'll say 1 bit is fixed. Correct? In case of class A, 1 bit is fixed. And that is always 0.
1.
0. Remember? Let me show you. Correct? So that is always 0. So this bit we cannot change. So if I say total bits for manipulation, how many bits I have for manipulation? Total 8 are there. Out of them, 1 is reserved. So I have total 7 bits for manipulation. So how many networks I can design here? So if I say total number of networks. So whenever you want to calculate such things like total number of network, total number of host per network, just whatever is the number of bits that you write in the power of 2. Okay. So here, how many bits we have for manipulation? 7. So simply say 2 raised to power 7. What is the value? 2 raised to power 7, 128. So 128 means the range will be starting from 0 till 127. Do we have this range in the class C? Correct? Okay. Now out of these, we know two networks we cannot use. What are they? 0 and 127. Okay. So 0 is not used anywhere. And 127 is reserved for loop back. So again, two reservations are there in class C. So if I say total usable networks, then I have total networks what? 2 raised to power 7. And I have to reduce 2 more. That will be 126 networks can be designed in case of class E. 126 usable and total 128. Okay. Now, if I want to calculate that, okay, if I design one network of class E, then how many addresses I will get? Because we see that in case of class C, only one octet is there. So 0 to 255, total 256 are there. But in case of class A, if I decide, let's say if I give you an example, again, remember 1.2.3.4, correct? So if we write, this will be 255.0.0.0, correct? Means IP range will start from 1.0.0.0 till 1.255.255.25. But how this range will come? This will become 0.255, then 1.0, then 1.255, then 2.0, right? Then at the time it will become 255.255, then 1.0.0, 1.1.0.0, then 1.01, 1.02. Like this will keep on increasing until 255, 255, 255. Correct? So we need to calculate total number of addresses. That okay, how many addresses are there? From here to here, 256. Then again from here to here, 256. Again here to here, 256. Like this will keep on adding and adding and adding. Right? Multiple times it will keep on adding. So we need to calculate this. And how do we calculate this? See. Total number of hosts per network. Okay. So how many host bits we have? So this you have to calculate as 2 raised to power host bit. How many host bit we have here? 24. Correct? Now you do not need to remember the exact number here. Okay. So 2 raised to power 24. That will be 1 crore 67 lakh 77,216. These many addresses in one network. Means these many PCs can be connected in one network. If you are keeping the first octet constant and changing the remaining three octets, these many addresses you can, or these many possible number of addresses you can get. But again, let's say, for example, easy example, I go with a 192.168.0.0 till for class C, 192.168.0.25. This will be the range. Okay. Now, when we are using this range, so in this range, we cannot use the first address and the last address. In any network, you cannot use the first address and the last. Why? The first address is reserved for network ID. This is how we define that, okay, we belong to this network. Okay, so this is reserved for network ID, and the last address, your last address is reserved for the broadcast address for that network. Means if you want to ping the entire network, just ping this last IP and the ping will go to the entire network. Means for broadcast traffic. Is that clear? Let me show you. See, if I open my network configuration, IPv4, use the following address. See, if I will assign any random IP in between, let's say 0.1, okay, automatically taking the subnet mask. Let me say okay. No error. Do not have any error, right? Now let me do one thing. Let me try to use this first address. Instead of 1, let me make it 0. You will get an error. What this error says? The combination of IP address and subnet mask is invalid. So we cannot use it. The first IP is reserved. Similarly, why it is reserved? See, all of the bits in the host address portion. What is the host address portion here? The 4th octet of the IP address are set to 0, means all the host part is 0. Is it 0? Correct. This is 0. Let me try to use the broadcast address. That is 255. The combination of IP address and subnet mask is invalid. All of the bits in the host address portion of the IP address are set to 1. That means 255. Clear? So the first IP and the last IP, the first address and the last address of any network we cannot use. Okay. So that means these two IPs we cannot use. So total how many IPs are there? 0 to 255, 256. Now again 2 we cannot use. So how many we can use? 254. Okay. So the first address and the last address are reserved. Okay. So if I say total number of usable IP address, that is 2 raised to power 24 minus 2. Okay. You do not need to remember the exact number. Okay. You can just say 2 raised to power 24, 2 raised to power 24 minus 2. Clear? And this thing you can note down that in any network, the first IP and the last IP is reserved. Okay. Your first IP is reserved for network ID and the last IP is reserved for broadcast address. This thing is clear? Noted? Okay. So if I start writing IP range for class B, and if I take an example here, so let's say, for example, 10.0.0.1. Okay, this is the IP. So according to this, the starting IP will be 0. Okay. Then next IP will be 10.0.0.1. The next will be 10.0.0.2. Similarly, the last IP will be 10.255, 255, 255. What will be the IP just before this? 10.254. Okay, you are saying 10.254.11. Network part we need to keep constant, right? Two five five dot 255.254. Correct. Then only next address will be 255. If you are saying 10.254.255 like that, let's say for example 255.255, the next address will be 10.255.0.0. like this. Okay,
As sir,
yes.
so, our address is 10.0.0. Should we change first zero or last one? I mean, from left side or right side?
You're saying this one,
From this one or that one?
the fourth octet, always fourth octet, then third octet, then second, then first. Okay. Okay, so the first IP, it is reserved for network ID, correct? So I can say this is what my network ID. So if I'm using any IP between these range, then I'll say to which network I belong. What is my network ID? 10.0.0.0. I belong to this network. Okay, and what is my broadcast address? This is my broadcast address. Correct. Then what are these IPs in between? These are known as valid IPs. Okay, so if I say this one, this is my first valid IP. This is my first valid IP, and this is my last valid IP. This is the calculation for class. Okay. Those who have done, they can try the calculation for class B.
Even range.
Hmm?
Range.
Range? No, right? We just started from where? Just with the network bit and host. So this calculation you have to understand. Noted? Then next, let's start for class B. Okay, class B. How many network bits? 16. How many host bits? 16. So if I say total bits for manipulation, I mean total network bits first. How many total network bits I have? 16. How many bits are fixed? 2 bits are fixed. Okay. That means total bits for manipulation. I have 14. That is 16 minus 2. 14. Okay. So if I want to calculate total number of networks now, that will be 2 raised to power 14. That will be 16,384. These many networks we can design in case of class B. Okay. If I say total number of host per network. So how many host bits I have? 16. That means 2 raised to power 16. So I'll have 65,536. But again, can I use the first IP and the last IP? No. So we'll say the first IP and the last IP are reserved. So total usable IP address equals to 2 raised to power 16 minus 2. That will be 65,534. Okay. So if I try to write a range here, okay, let's say 172.16.0.0. This is the first IP. Then 172.16.0.1. Okay. Then this will end at 172.16.255.25. Correct? What will be the address just before this? 172.16.255.254. Correct? Okay. So this first address will be my network ID. Then I'll have first valid IP. I'll have last valid IP. Then I'll have my broadcast address. Noted. Okay, class C. How many network bits? 24. How many host bits? 8. So if we say total number of network bits, we have is 24. How many bits are fixed? 3 bits. So total bits for manipulation. How many we will have? 21. 24 minus 3. That is 21. So if we say total number of addresses or total number of networks, that will be 2 raised to power 21. That will be 20,97,153. Okay. Now, total number of hosts per network. Total number of hosts per network. So how many host bits we have? 8. That will be 256. But again, the first IP and the last IP is reserved. The first IP and the last IP are reserved. So total number of usable IP address. That will be 2 raised to power 8 minus 2 equals to 250. Okay. And if we write the range, let's say 192.168.0.0. Next address will be 0.1. Last address will be 0.255. What will be the last valid IP? 254. So the 192.168.0.0, what it is? Network ID. Then this will be first valid IP. And then we have last valid IP. Then we have the broadcast address. Noted. Now all the things we'll just create a table and then summarize. So again, we'll have class, then we'll have default subnet mask. Okay, then we'll have network bits, host bits, number of networks, and number of hosts per network. Okay. Okay. Class A. Default subnet mask 000. Network bits,
Eight.
8. Host bit, 24. Number of networks. So 1 bit was reserved. So 2 raised to power 7. 1 bit is fixed. So 2 raised to power 7. And number of hosts per network, 2 raised to power 24 minus 2. Okay. And here also you can do 2 raised to power 8 minus 2. Because total 8 we have, but 0 and 127 we do not use. So 2 raised to power 8 minus 2. In case of class B, we have 255, 255, 0.0. Number of network bits, 16. Number of host bit, 16. Now here, how many bits were reserved? Okay, wait a minute, let's make it 2 raised to power 7 only. Otherwise, there will be confusion. Okay, here we'll do 2 raised to power 16 minus 2. Or 2 raised to power 14. Then this will be 2 raised to power 16 minus 2. Plus C. 255, 255, 255 dot 0. This is 24. Host bit 8. Number of networks 2 raised to power 21. And here 2 raised to power 8 minus 2. This is clear. If you want, you can subtract from here 0 and 127 also. So you can add minus 2 also. If you want to subtract, that will be the usable number of networks. And this is the total number of networks. Okay. So that thing also you can do. That we do not use 0 and 127 in case of class A. So that will be subtracted. Okay. The next thing sometime you'll come across, see, subnet mask is not always given as 255, 255 like this. Okay. Sometimes it is given in the slash notation also. Okay. This is also known as slash notation, CIDR value, prefix length. Okay. These kind of words are used. What it is, see, you will be given one IP address. With the IP address, a slash value will be written like slash, and after that slash, number of network bits will be written. Number of network bits will be written. Okay. So if you want to calculate for class A, how many bits we have? Number of network bits in class A. So if I want to write subnet mask for class A, slash A. That is class A. What about class B? 16. So that will be slash 16. Class B. What about class C? Slash 20. That is class C. So how the IP addresses will look like with the subnet mask? They will look like, let's say 10.0.0.1 slash 8. Okay. You will see 172.16.1.10 slash 16. You will see 192.160.10.1 or 10.11 slash 20. So just by looking at this slash value, you must come to know that, okay, these many network bits are there. Okay. So this is also sometimes known as slash notation, CIDR or prefix length. So if you see something like this in the question, whether CIDR value or CIDR notation, CIDR equivalent, so means they are just telling you about slash notation. Noted? Okay. Now see, in case of subnetting, what kind of questions you will see? You will be given one IP address, let's say 10.11.12.13. With that, you will be given a slash value or subnet mask. Okay. And then you will have to tell the network ID and the broadcast address. So for this IP address, what is the network ID and broadcast address? Network ID is 10. Complete IP address 10.11. How? Slash value is 8. Only first octet is network.
10.0.0.
Slash 8 means 8 network bits. 8 network bits means remaining are host bits. That means only first octet is the network, remaining are host. See, if you write slash 8, according to slash 8, what will happen? Total number of bits in IPv4, 32. Out of them, 8 is network. So how much is host? 24. This part is network, remaining 3 are host. Okay. And when we set the host part to minimum, that will be your network ID. Host part maximum, broadcast address. So what will be the broadcast address here? 10.255.255.255. Correct. What about what will be the slash value here? 16, right? What will be the network ID? 191.1.0.0. Correct. Broadcast address 255.255. Okay. What will be the slash value here? 24. 24. Correct. Are you sure? Which class? D. No subnet mask. Individual address. Okay. Do not get confused. Now there will be a network ID and there will be a broadcast address. Network ID will be 0.0.0 and broadcast address 255. Okay, so like this kind of questions you will get. Noted. This thing is clear, right? Now, one more small concept we have. Public and private IP address. So what does it mean with the public?
The expressions that we use in common use. Like in Google ID. So private use we are using in the registration.
Private means LAN area networks.
Okay,
And public IP address means wide area networks.
okay. See, just go with the word. Public means anyone can access, available for public use, and private use means specific. Correct? Okay. So what will happen? There are some addresses that are available for public use. Means that can be used around the world. But there are some addresses that can be used inside private environments only. Okay. Now, how these addresses are different? So first of all, we'll see the differences between the pure private and public addresses, and then we'll discuss. So one side will have public. Okay. One side will have private. Your public addresses, they are used in the WAN side, means wide area network. Okay. And these are used in the LAN. What is a LAN? Local area network. That means a private network. Okay. First thing. Second thing, your public IP addresses. Now, if we are using on the internet, so any IP address, why it is used? To identify a node. Any IP address is used to identify a node. So if I want to identify something around the world, that has to be unique. Let's say if I want to identify Google, so the IP for the Google should be unique. That should be unique around the world. I should be able to access Google from anywhere, right? So that has to be unique. So these addresses, your public addresses, these are globally unique. They do not repeat anywhere. Oh, so globally unique. These are globally unique. Globally unique means cannot be reused. Okay. These are cannot be reused. And your private addresses. Now these are in the local area network. So these have to be unique only inside the local area network. So you can say these are unique in LAN only. Okay. So if these are unique only inside local area network, so if there is a different local area network, there these addresses can be reused. Okay. So we can say can be reused in different LAN. These can be reused in the different LAN. Okay. Then now, whenever you want to use internet, are you able to use the internet for free or you have to pay for it? You pay, right? You in the mobiles, you get the recharge. If you are taking broadband connection, you have to pay every month or whatever your plan is accordingly. Okay. So basically, these are paid addresses. You have to pay for these addresses. And these are the free addresses. Anyone can use them for free. Okay. These addresses. Now, when you take a broadband connection from your router, so on your router, do you set the IP or the internet service provider? Who gives the IP to your broadband? Your ISP. You do not manually assign. You just assign the IP addresses on the LAN side. Okay. So see here, this is assigned by internet service provider, and this is assigned by admin. Okay, the network admin, you can see. Okay. With the public IP, we are able to use the internet. With the private IP, we cannot use the internet. If I connect a switch, with the switch, I connect few systems, computers, they will be able to communicate. Why? Because I will be creating a local private area network or local area network, a private network. Now those systems will communicate. In them, I will assign the IPs, so they are still my private only. Correct? Will I be able to use internet? No. Why? Because I'm not connected to my ISP. And when I'm connecting to my ISP, I'll be using what? This public IP. Okay. So you can say these public IPs, they are routable on the internet. Means you can use internet with the public IP. And your private IPs not routable on the internet, means you cannot use internet using private IP. These things are clear. Okay. Now see, from each and every class, 3 classes we are using, class A, B, and C. So from each and every class, some networks have been reserved for private addresses, and remaining other addresses, whatever we have reserved for private, other than that, everything is public. Okay. So if we discuss about your class A, if I say private reservations in classes, if we discuss about class A, or let me just make a table only. First of all, class, number of private networks, that how many networks are reserved, and the range. Private IP range, and remaining everything will be public. First of all, class A. In class A, one network is reserved. In case of class A, one network is reserved, and that private range will start from 10.0.0.0, and only one network. That means where it will end. Network part constant, only one network we are talking about. If you see any IP starting from 10, that means it is a private IP. If you see any IP starting from 10, that means it's a private IP. Then in case of class B, total 16 networks are reserved. Okay. And the range starts from 172.16.0.0 till 172.31.255.255. These are 16 networks. Because if we see in case of class B, which part is network? This much part. Correct? So network part is changing from 16, then 17 will be different network, 18 will be different, 19 will be different, 20 will be different. So till 31. So 16 plus 16, how many? 32. But we are starting from 16 itself. So count 16 also. So it will go till, let's say, for example, I have total 8 networks, right? But when I will start the range, it will be 0 till 7, right? So if I start next 8 networks, so here I'll say, okay, 8 plus 8 is how many? 16. But when I'm saying 8 plus 8, I'm not counting the 8. See, after 7, 8, 9, 10, 11, 12, 13, 14, 15. So how many? 1, 2, 3, 4, 5, 6, 7, 8. Okay. So that means from 16 till 31. How many networks? 16. Or else you can count like this: 21, 22, 23, 24, 25. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then 26, 27, 28, 29, 30, and 31. Now you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So total 16 networks are reserved. In case of class B. In case of class C, total 256 networks are reserved. And the range starts from 192.168.0.0 till 192.168.255.255. Are these 256 networks? Check. What is the network part? First 3 octets. And my network octet is changing from 0 till 255. Means 0 is one network, 1, 2, 3, like this till 255. So total, how many networks are reserved? 256. So if you see any IP that is starting with 192, 168, 172, 16 till 172, 31 and 10, that means it is a private IP. And remaining everything is public IP. Okay, now let me check my own IP addresses. Yes.
In class A,
Hmm.
the range you given, it is more than 256.
How?
168.0.0
Mhm.
and it is going to 168.255.0.
But only my network part is 3 octets.
So
This
the
part
third
is
bit will
host.
remain
This
zero.
is just an IP address. This is not a network. This is host part, right? So host part is what? Just an address, IP address.
The third bit there, dot zero.
Yes, .0 till 255. This is my network part, right? In case of class A, only this part is network, so we are just focusing on this part. Not changing, only one network. In case of class B, only 2 octets are my network part. Changing from 16 till 31. That is 16 networks. Similarly, in case class C, 3 are there, right? From 0 till 255. So this is how 256 networks. This 4th octet will not consider. If you start considering 4th octet, means the host part also. So here we have 2. So this will be even more. Okay. So just focus on the networks. What we are saying here, private IP range. But here we are discussing only number of private networks. So means we are just focusing on the network, not the host part. Okay. Still confused? I know why your confusion is, because you see, according to this thing is same here. That's why you're getting confused. But okay, here also 0.0 till 255, and here also 0.0 till 255. But actually just focus on the network part. How much part is your network? Then it will automatically get clear. In case of class A, only this part is network. So just focus on this part, how much it is changing. In case of class B, this part is network. So just focus on this part. Do not consider the other part. And in case of class C, this much part is the network. So how much it is changing? 0 till 255.
Third bit also you change, no?
Yeah, third bit, because 3 octets in case of class A. If we discuss in case of class A, 8 network bits, 24 host bit. Here, 16, 16. Here, 24, 16. So that means here 1 octet is network, remaining 3 host. Here 2 octets network, 2 octets host. Here 3 octets network, and 1 octet is host.
The third bit will not change, sir.
Why?
Change that 168.255.
So how many networks I'm considering here?
In private IP ranges, 192.168.0.0.
Correct.
It's going to 192.168.255.255. So it will not go 192.168.0.0.
No, I'm writing IP range. for these many networks. This is not one network. This is not one network. These are 256 networks. This means these many total private IP addresses are there. Okay. See, if you consider this way, then you will say that, okay, this is from 16.00, then why it is 31.255.255? The same question can come here also. That why it is 31.255.255, it has to be 16.255.255 only. But that time only one network. That means, see, if I want to write my 256 networks, in case of class A, I have only one network, so this is clearly understandable. In case of class B, I have to reserve how many networks? 16. So my first network will be 192.160, let's say 172.16, 0.0 till 172.16, 255.255, correct? Then this is one network. How many I have to reserve? 16. So my next network will be 17.00. Then, sorry, 17.255.255. The next will be 18. Then last will be. So I'm writing for the first IP and the last IP. This is how this thing is coming. Similarly, in case of class C, if I'm reserving only one network, it will be 192.168.0.0 till 192.168, 0.255. This is one network. My next second network would be 1.0 till 1.255. Now, how many I have to reserve? 256. So means like this, I will keep on writing 192.168.255.0 till 192.168.255.25. Correct? So instead of writing these many ranges, I have written just first IP and the last IP. Is that clear? Okay. Okay, so let's say, for example, I have this IP address. Public or private? Private, sure. Public. Because not falling in 192.168. Okay, so this is a public.
That would be range like
Yeah, all the entire range other than this addresses, everything is public. Okay. Okay, what about public? Private or public?
private.
Private. Okay. What about my IP addresses? Private or public? See, I'm able to use the internet also. Then why? It is private or public? Private. What about this one? Private. This one? Private. Right? See, these are what? Private IPs. How public IP will be and how you can check your public IP. Just go to any browser. Let's say even in your phones also you can go to Chrome. Okay. And in the Chrome, in the Google, simply say what is my IP address. What it is now. My public IP. And what it is saying? 106. So 106 is there falling in this range? No, right? So this is a public IP. So if you are using internet in phone, you will be getting a public IP inside your phone also. Okay. So anything other than this range is all public IP. So you can see in my local area network, I'm using a different IP. And when I'm going to the internet, I'm using a different IP. Okay. So this is kind of scenario, what is happening. This is your internet. Then from the internet, you have taken a connection and they give you a router. Let's say this is my Wi-Fi router. And from here, let's say I have connected my PCs and everything. So in my local area network, let's say I have connected a switch also here. And with the switch, I have connected the devices. Now here I'm using private IP. And this side, on the internet side, I'm using a public IP. So how I'm able to go and use this public IP? So there is a process that is known as NAT, Network Address Translation. Okay, that will discuss that how this NAT is working and how you are able to use internet. That how you are able to use two different IPs, one in the private and one in the public. Because if you see in your computer, you can just assign one IP. Okay, if you see, and let me show you here also. Means you can assign multiple IPs, but still, if you see on my interface, let's say my Wi-Fi card, and if I show you all my IP addresses, so you can see how many IP addresses, only one. That is 172.16.1.1. Then where is the 106 IP? That is available on my router. So what my router is doing here? Let's say this is my IP, 172.16.1.1. Okay. So whenever I'm trying to go to the internet, so my private IP is coming here to the router. What router is doing? Changing this IP, 1.111, changing it to the public IP, that is something 106 and the IP. Then when the reply is coming to my public IP, my router is changing it back to this IP, and then I'm having the communication. But that thing you'll understand with the NAT, Network Address Translation. Okay. This is clear. So for using the, see why we require this NAT and private and public concept, because how many addresses are there in case of your IPv4? 2 raised to power 32. That is somewhere around 4.3 billion. Correct. Number of addresses is limited. Are there only 4.3 billion devices? See, right now, everywhere we are using IP. Smart watches, okay, smart, everything is getting smart, right? Smart TV. So everything that is connected to the internet is using what? IP address. Everybody is having 2 phones, 3 phones, okay, laptops, tablets, everything is using like cameras and everything. So are there only 4.3 billion devices that are connected to the internet? No, far more than that. But still we are able to use the internet. Every device is able to use the internet. Why? Because of this one is public and private concept and the NAT. Okay. Your IP addresses are limited. So in the 90s, in the 1990s, what happened? The Internet Authority, they already knew that IPv4 will not be sufficient. So they started working on new schemes. So they came up with few concepts. One was your IP version 6. That is having larger number of addresses. Second thing was your subnetting, also known as CIDR. Okay. Third thing is your NAT, Network Address Translation. Okay. So CIDR we'll discuss tomorrow. That is classless subnetting. Okay. NAT also we have, and IPv6 also we'll discuss. All these 3 things we'll discuss. Okay. And once we discuss NAT, you will be able to know that, okay, still we are able to use IPv4 addresses. How? Because number of addresses are limited, number of devices are more. So that thing will be clear when we are going with the NAT. Okay. All right. So any doubt so far?
Ajay, I have one doubt. Actually.
Yes,
So,
please. All right.
like whenever we have a device in our home or anywhere else, right? Always it is configured with the private IP only.
Correct.
So any device whichever we are connecting to the internet also, it has been configured with the private IP only.
That public IP is already configured on your router.
Okay, okay.
Okay, so your router is translating the IPs.
Okay, okay.
Okay. That's why we are able to use. And only one IP is configured on your router, and still you are able to use internet in multiple devices. Let's say, for example, Doesn't matter how many students and faculties and anyone who is connected to the same Wi-Fi, they will use the same IP. If anyone is connecting to the third floor, that means they will use this same public IP. So how multiple people are able to use internet using the same public IP, that concept will also be clear in the NAT only. Okay, we have static NAT, dynamic NAT, and PAT. Okay, port address translation. So there it will be here that how, see, with one IP address, we can use internet in around 65,000 systems. Okay, so everything will be clear with the NAT. Okay.
And that only existing IPv4 or it is also existing.
See, this feature is available in IPv6 as well. Okay, but right now the number of addresses is used. We do not require it. But this feature is available, so when it will be required, we can perform also. And we have something called as NAT 64 also.
Yeah, when I try to get the IP address of mine, right, I'm getting IPv6.
V6, yes. Because see, right now your internet completely working on the V6, but still some devices and some vendors, they are providing you IPv4 IP. Let's say if you are using in your cell phones, if you are using Zio, so Zio's network is completely based on IPv6. Okay, so if you are using a Jio SIM card and if you go to the internet and say, what is my IP address? Most probably you will get an IPv6 address only. Okay. Yes. And slowly, everyone is shifting towards the V6, but still IPv4 will be used. Okay. See, in your book, if you see here, let me show you. Okay. That your addresses, IPv4 addresses were already exhausted. Whatever the last entries were there, they were delivered in 2015 itself. But right now, 2023, and still using it. Values. Read this now. The universe has run out of public IPv4 addresses in a couple of significant ways. INA, this is the authority that is handling all the IP addresses. Internet Assigned Numbers Authority, which assigns public IPv4 address blocks to 5 regional internet registries. See, on the top, we have INA. Okay. Then this is delivering the addresses to, there are total 5 internet registries inside around the world. RIR, regional internet registries. So INA assigns the addresses to them, then your ISPs contact the INA regional internet registries. From there, they take the IP addresses. Then from there, your service providers and directly you get the addresses. This is how these are delivered. So they have delivered the addresses to the 5 internet registries and they are delivering to your service providers and everything. This is how step by step we are getting the IP addresses. So your INA, which assigns the public IPv4 address blocks to 5 regional internet registries around the globe, assigned the last of the IPv4 address space in early 2011 itself. They assigned. And by 2015, the ARIN, the regional internet registry for North America, exhausted its supply of IPv4 addresses. Because earlier when the IPv4 was designed, so they didn't think that, okay, internet will grow so fast and so big. So they assigned the complete networks itself. Let's say in class A network, if some company is requiring addressing, so they will assign all 11.0 range, 12.0 range like this. Now, they ask the companies to return the unused public addresses. So companies must return the unused public IPv4 address to ARIN before they have more to assign to new companies. Because see, they do not have, they have given already in the 2015. So they are asking the companies to give them back the public addresses that are not being used. Okay. So the internet community worked hard during the 1990s to solve this problem, coming up with several solutions, including your IPv6, your CIDR, and NAT. And with the NAT only, we have the use of private IP addresses. Okay. So all these three concepts we are going to discuss one by one. So tomorrow, what we'll be discussing, subnetting or CIDR. So this, what it is going to do, assigning a subset of public network to each company instead of entire public network. Means instead of using one complete network, let's say class A, what very big network, 1 crore addresses, right? So every company do not require that many addresses. Okay. So what we can do, we can assign a subset or small part of that network. We can break down a network into smaller parts. That is what your subnetting is. Why? To reduce wastage of IP addresses. Because say, let's say if I'm using, for example, as of now, I know that if I'm using a class A, if I'm using a class A network, that means how many IP addresses I'm getting? 1,67,77,216. Okay. If I'm using a class B, 65,536. If I'm using class C, I'll get 256 addresses, right? So if earlier, when there was no CIDR concept, when there was no subnetting concept, if you require, let's say 300 IPs, now what? Cannot go with class C, we'll go with the class B. So with class B, 65,536 addresses I will get, I will use 300 only. How many I will waste? 236. If my requirement becomes, let's say 66,000 only, then I'll move on to this one. And I will waste more than 1 crore 67 lakh addresses. So that's why they came up with the CIDR concept. Okay. And with the CIDR concept, we are able to use the IPv4 till now. Okay.
Okay, clear.
This is clear?
Yes. Let us consider another one question. You have IP, right, for your host. So if you are changing the IP address of your, like the private IP of your device, right? So
actually, you're not audible. Can you please speak louder?
Hello?
Yes, please.
Actually, let us consider your PC is having some IP address. Like, let us consider you are having some 172.16 something you are having, right? So
Okay.
you're planning to change your IP address.
Correct.
So that may be hit in, like, let us consider if you are changed, right? Someone maybe use that IP address also, right? At the time, whether it will ask, whether it may ask you to configure or it will show some error for you. Whether we can able to change, right, that IP address.
Yes, statically you will be able to change, but if you are using a DHCP, then in that case, DHCP will never assign the same IP again.
Okay.
Okay. So in the enterprise networks, when we have more than we have lots of systems, so we go with the DHCP concept instead of static.
Okay. Okay. Clear.
Yeah. So we'll see all these things, that how you can configure a DHCP server and how your DHCP server is assigning the IP addresses, what is the backend process, all these things we'll see. Okay, so any doubt in this part? Today's part? Task for you tomorrow, classless subnetting. You have to check. Okay. No doubts in today's part? So I'll stop the recording.